I want to talk to you physics guys about free fall and a problem that talks about dropping an object from a specific height and then going ahead and finding out how long it takes and how fast it's going just before it hits the ground. Okay. Problem says Mr. Sokol drops a brick off a 30-meter cliff. And what is the velocity of the brick just before it lands? Great. So I'm looking for final velocity, but I need time, right? I don't have time. That's why I asked how long does it take? So what did I do? I reconfigured because there's no initial velocity because I start by holding the brick and then just letting it go and it starts from 0. So there's no initial displacement and there's no initial velocity. So I get rid of the xi and the bit, and I just reconfigure 1/2 at squared to find time. Here it is. Time is going to be equal to the square root of 2 times the height divided by the acceleration. Well, what's the acceleration? The acceleration is that acceleration due to gravity. So what was I given? I was given a height of 30 meters. What is my acceleration? My acceleration, we talked before about unidirectional problems. We're just talking about this object going in one direction from here all the way down to the ground. So we're going to make, sorry, just kicked the plug out. We're going to make acceleration for this type of problem positive. It's only going in one direction. Why make it negative? Then we would have to make this negative, yada, 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 blah, blah, blah. We don't like a negative inside a square root anyway. Here it is, 9.8 meters a second squared. And then what are we looking for? We're looking for the time. And then afterward, we're going to look for our final velocity. And what we'll need later on is our initial velocity, which happens to be 0 meters a second. Remember, what's our least precise measurement? We're going to round to the nearest whole number when we talk about seconds. So here we go. What does it say? Well, let's use our first part. So t is equal to the square root of 2 times 30 meters. Harry. There we go. 2 times 30 meters divided by 9 8/10 meters a second squared. This is cool because look at what we've got here. I'm going to keep going. Time is equal to the square root of 60 meters over 9 8/10 meters a second squared. And I'm going to use my handy dandy calculator here. There we go. Come on, turn on. There you go. What is the square root of 60 divided by 9 8/10? And the square root of that is, and I'm going to cheat here, and don't be mad at me. It's going to be 2.5 seconds. It's 2.47 seconds. I don't want to round it down to 2, and I don't really want to round it up to 3. I want to talk about the 2.5. It's just about 2.5 seconds. So all of that talk about precision, my least precise measurement, sometimes we have to fudge. There we go. Meters cancels out with meters. The square root of seconds squared is seconds. Excellent. We've done a beautiful job. So now my time is just about 2.5 seconds. Well, Now that I know that time, I can tell you what my final velocity is because I don't have any initial velocity. All I have to do is multiply my acceleration times that time. And if you think about it, look, 2 seconds would be, the first second would be 9.8 meters a second squared, 9.8 meters a second. And then there'd be another 9.8 meters a second. And that would be 19.6 plus half of 9.8, which is 4.9. So what is 19.6 plus 4.9? That is 24 and 5/10, right? It should be 24.5. Let's see. I'm going to write it up here. It should be 24.5 meters a second. Is that right? Did I do that right in my head? Anyway, let's put it into the formula. V final is going to be equal to 9 8/10 meters a second squared multiplied by, I got to move this, don't I? I'll put it up here in this stop level, 24.5 meters a second. Okay, and we're going to multiply that by our 2.5 seconds. Sorry about wasting your time there. So we'll put it into our handy dandy calculator. 9.8 times 2.5. Oh, 24.5. We got it right. So I got to remember, I'm multiplying here, right? The seconds cancels out with one of those seconds, and I've got meters a second. Do you know what that means? I have a velocity number. Awesome. We did beautifully. So even though Mr. Sokol tells you all the time that we go with our least precise measurement, sometimes I want you to round to the nearest tenth or so. And I'll let you know when we're doing these problems in class what I would like out of you, because I don't really like 2 as a time in the air because it's 2.5. And if we didn't put that half there, this would be down to 19 6/10 meters a second. And it's going a lot faster by the time it hits the ground. It's pretty darn fast. So Mr. Sokol had to make sure there was nobody underneath that brick when he dropped that brick, when he dropped it from that cliff. Have a great time. Thanks for watching.